let's get started. First, we got to factor the top and the bottom. I believe we had this factored in class, and it ended up being x squared plus 6x plus 8. So that's x times x plus 4, x plus 2. Then you have negative 3. X is my GCF times x plus 3. All right. I notice that x over x is 1. Anything that reduces is a whole. So we have a whole at whatever makes this factor, the factors that are being crossed off, equal to 0, which is literally x equals 0. So a whole at x equals 0. Vertical asymptotes. Vertical asymptotes are anything else in the denominator that makes it equal to 0. X plus 3 equals 0, so my vertical asymptote is x equals negative 3. All right, your horizontal asymptote. All right, the horizontal asymptote is dependent on the degree of the numerator and the degree of the denominator. So this is 3, this is 2. 3 is greater than 2. So when the degree of the numerator is greater than the degree of the denominator, there is no horizontal asymptote. All right, x-intercepts. Whatever makes the numerator 0 will also make the denominator, well, will make the denominator obsolete. So anything that makes the numerator 0, the whole thing will be 0. So my x-intercepts, I have 2 of them. Whatever makes this 0, which is negative 4. And whatever makes this 0, which is negative 2. Okay, so I have a vertical asymptote at negative 3. And I have no horizontal asymptote. I do have some x-intercepts at negative 4 and negative 2. All right, and now I'm going to, we do need to find domain and range. The domain, let's graph it first actually. So I want to graph 2 points to the left and the right of the vertical asymptote. We already have 1 point to the left and the right, so we also need to plug in negative 5 and negative 1. Okay, so I'm going to plug it into the factored version, which is a little bit more simplified. Okay, so negative 5 plus 4, negative 5 plus 2 over negative 3 times negative 5 plus 3. Notice how I did not include the x's. Negative 5 over negative 5 would just be 1, so it's not relevant. Okay, so then you have negative 1 times negative 3 is 3 over negative 3 times negative 2 is 6. 3 over 6 is 1/2. And then when we plug in negative 1, we get negative 1 plus 4. Negative 1 plus 2. Negative 3, negative 1 plus 3. This is 3 times 1, negative 3 times 2, negative 1/2. All right, so I have a point at negative 5 1/2. And at negative 1, negative 1/2. Because this is an overall positive rational function, your branches will open roughly toward the first and third quadrants as opposed to second and fourth. and this is approximately what it would look like. Your domain is all real numbers, but it cannot be any wholes or asymptotes, which would be -3. And your range is all real numbers, except any horizontal asymptotes, and you don't have any, so you're done. Let's do the following. Okay, factor, factor, factor. This is x plus 2, x minus 2. This is 2 times x minus 1. Okay. It appears as though... Oh my goodness! I didn't do the whole. I totally forgot about my whole. I have a whole at 0. So, at this point in time, we will erase the whole, or you can white it out. And then we would draw that hole in. Wow, that's really not a pretty hole. Okay. Learn from me. Don't forget the hole. Okay. So, it appears as though nothing crosses off, nothing reduces, so I do not have any holes. Vertical asymptote. Anything that makes the denominator equal to 0. So, -2 and +2. So, plus or minus 2. I have 2 vertical asymptotes. I'm going to draw those out right now. -2 and +2. Okay. Then I need the horizontal asymptotes. Okay, horizontal asymptote depends on the degree of the numerator and the denominator. The degree of the numerator is 1, denominator is 2, 1 is less than 2. Therefore, you have a horizontal asymptote at y equals 0. X-intercepts zeros of the denominator, of the numerator. My bad. You only have 1, it's whatever makes this 0, which would be 1, comma 0. Alright, so I'm going to put a point there. And I don't have to remember any holes. I'm going to draw my horizontal asymptote. What the heck? There's literally an intercept on top of the horizontal asymptote. Why is this happening when Miss Aureli always told us that we could not cross or touch an asymptote? Guess what? You can cross a horizontal asymptote when it is between 2 vertical asymptotes. So it's like the 2 vertical ones negate the horizontal just between. It's over here and it's over here, but in between, it's okay. I do not have a good reason for why. I should probably research that. I'll get back to you. All right, so this means we need to plug in 2 values to the left, 1 more value in the middle, and 2 values to the right. So this is where I'm going to do my work. I'm going to plug in -3 and -4. So -4, -3. There's an asymptote. 0 looks like it's the easier one to plug in. You already have an intercept there, and then 3 and 4. All right, so this is where I'm going to do my work, and then this is where I'm going to put the answer. 2 times -4 minus 1 over -4 squared minus 4. I think it might actually be easier to plug these in to the non-factored version. All right, that gives me Okay, that gives me negative 10. Negative 5 times 2. 16 minus 4. Okay, over 12, which is negative 5 over 6. All right, so 2 times negative 3 minus 2 over negative 3 squared minus 4. That is negative 6 minus 2 is negative 8. 9 minus 4 is 5. Negative 8 over 5. All right, plugging in 0 leaves me with negative 2 over, so 0 minus 2 over 0 minus 4, so that's 1/2. 3, when I plug in 3, I get 2 times 3 minus 2 over 3 squared minus 4. So again, I have 6 minus 2 is 4. 9 minus 4, so 4/5. And then plug in 4. And I get 2 times 4 minus 2 over 4 squared minus 4. Okay, so 8 minus 2 is 6. 16 minus 4 is 12. That's 1/2. All right, let's plot these points. Negative 4 is down negative 5, 6. Negative 3 is down negative 8 over 5. That's between 1 and 2. It does not have to be super exact. 0 goes up 1/2. 3 goes up 4/5. And 4 goes up 1/2. Okay, I think I know what's happening here. I think this is like an inverse cubic one, okay? But we can always check by plugging in more points. I'm not going to because my phone might die in a second. So here's a branch. Ooh, don't cross that asymptote. All right, and then here I have basically like a negative cubic function. And then, again, I am expecting that your graphs are prettier than mine, but there's the rest of today's lesson.